Welcome to the 12th video in the Pearson Geometry video series. Section 2.4, Slopes and Parallel and Perpendicular Lines, discusses two theorems. The first theorem, 2.13, says that all vertical lines are parallel and non-vertical lines with the same slope are parallel. Theorem 2.14 says a vertical and horizontal line are perpendicular and non-vertical lines are perpendicular if the product of their slopes is -1. All right, let's take a look at an example. Okay, the question is, are lines K and N parallel? All right, so let's check their slopes. If we look at K, we can find a point right here, and we can find a point right here. So if we use rise over run, this one is negative, so we're going to go down. So 1, 2, 3, 4, 5. So -5. And 1, 2, 3, 4. -5/4. Okay, let's check N. All right, we've got another point right here and a point right here. So we can do 1, 2, 3, 4. So we've got -4 over, and then 1, 2, 3. So -4/3. So we would have to decide or conclude that K and N are not parallel. All right, let's take a look at M and Q. We're going to do the same thing. So line M is right here. So we've got a point right here that's pretty clear and a point here that's pretty clear. So we're going to go up 1 and over 3. So that's going to be 1/3. And Q is right here. So let's see, we have a clear point right here. We have a clear point right here. So we're going to go up 2 and over 1, 2, 3, 4, 5. Okay, so let me double check that. 1, 2, 3, 4, 5. Yep. So we're looking at 2/5. So it looks really close. It looks like they almost could be, but these are in fact not going to be parallel. Okay. Now, keep in mind that parallel lines have to have the same slope. Close is not good enough. So let's take a look at this example down here. Okay, so we want to see if lines K and L are perpendicular. Okay, so let's figure out what those slopes are. K and L, definitely not parallel. We can say, here's a point right here, and here's a point right here. So we're going to go up 2 and over 3. So this one is going to be 2/3. And L, let's see, we'll find a point right, looks like here and here. So up 2 and over 1. So this one is just 2. So those are not going to be parallel. Close, but this would have to be -3/2. You would have to flip it and change the sign, and this one is not -3/2. So let's try M and K. Okay, so M is right here, and it looks like we have a point right here and right here. So this one is going to be down 1, 2, 3, 4, and over 1. So -4 over 1, which equals -4. And we already said that K was up 2 and over 3, so those two lines are also not going to be perpendicular. So an easy way to check, if you figure out what your slopes are and you multiply them together and you end up with -1, then they are perpendicular. The other way is that they need to be opposite reciprocals of each other. In other words, turn them into a fraction, flip it over, and change the sign. And if that's what you get, then you know that they're perpendicular. Okay, so the next thing that we're going to do is write equations using these two theorems. So to write an equation, this is just like it was in Algebra 1. You're going to find the slope. You're going to sub in the point and the slope into your original y equals mx plus b, solve for b, and then plug the slope and the b back in. Write your equation. Okay, so let's take a look at this one. We want to write an equation of the line through point P that is perpendicular to line L. Okay, so line L has a slope. Line L has a slope of 1/2. Okay, if we want this to be perpendicular, then we need the perpendicular slope which is going to be 2, and change the sign. So 2 over 1, and change the sign is going to give us negative 2. Okay, so that means y equals negative 2x plus b. All right, now we also want it to go through point P, so let's go ahead and substitute that in. The 1 goes in for the y, so 1 equals negative 2, and then the 4 goes in for the x. Negative 2 times 4 plus b, and then we're going to simplify. So 1 equals negative 8 plus b, and then we are going to add 8 to both sides. We get 9 equals b, which is what we wanted. We need our slope, and we need our y-intercept, so we can go ahead and write it and say y equals negative 2x plus 9. And that's going to be our equation. Okay, let's take a look at a couple more. Okay, let's say that we want to write an equation that is parallel to the equation in problem 2 and contains this point. Okay, so parallel means that we want the same slope, which in this case is negative 3. M stands for slope, by the way. Okay, so we're going to plug in that slope. We get y equals negative 3x plus b. And then we're going to plug in this point t. So 1 for the y. 1 equals negative 3 times the x, which is 3, plus b. So 1 equals negative 9 plus b. Now we'll add 9 to both sides and get 10 is equal to b. So now we have our slope, we have our y-intercept, and we can write our equation. So we're going to get y is equal to negative 3x plus 10. And it's done. All right, let's try another one. We want another one that is parallel. So it's parallel to this line right here going through this point. So our slope is going to be 3/4, which means y equals 3/4 x plus b. Okay, now let's substitute in point t, so negative 2 for the y. So negative 2 equals 3/4 times the x, which is 12, plus b. Okay, so we've got negative 2 equals, okay, 3 times 12 is 36, divided by 4 is 9. So we're going to get 9 plus b. We're going to subtract 9 from both sides and get negative 11 equals our y-intercept. So now we have our slope, we have our y-intercept, and we can write our equation. Y is equal to 3/4 x minus 11. Okay, does this seem familiar from last year? All right, now let's do the same thing from perpendicular lines. One thing that we can look at, if the slope of a line is a over b, what is the slope of any line perpendicular to it? Okay, and we mentioned this on the other page. So if we flip this over, we're going to get b over a, and we change the sign, so we would make it negative b over a. Okay, so now let's try a problem with a perpendicular slope. So our slope is negative 3. So that's the same as negative 3 over 1. So we're going to flip it over and make it positive. So our perpendicular slope is going to be positive 1/3, which means y equals 1/3 x plus b. Okay, now let's substitute point t in. So 1 for the y. So 1 equals 1/3 times 3 plus b. 1 equals 1/3 of 3 is 1. Okay, we're going to subtract 1 from both sides. We get b is equal to 0. So we have our slope. We have our y-intercept, but we're probably just going to leave it off. We're probably just going to say y is equal to 1/3 x instead of saying 1/3 x plus 0. Okay, let's do that again. Okay, we have a slope of 3/4, so we want to flip it over. So our perpendicular slope is going to be 4/3, and since this is positive, we'll make that negative. So we're looking at y equals negative 4/3 x plus b. Okay, now let's substitute our point in. So we've got negative 2 is equal to negative 4/3 times 12 plus b. Okay, and negative 2 is equal to negative 4 times 12 is 48. Divided by 3 is negative 16, so negative 16 plus b. We'll add 16 to both sides, and we'll get 14 is equal to b. So now we have our slope and we have our y-intercept. So y is equal to negative 4/3 x plus 14. And that's all there is to it. Catch you later.